Hello and welcome back to another episode of Math with Stone. Today we are going to be completing the square to solve some quadratic equations. So the first thing I'm going to do is tell you that in order to complete the square you have to get the x squared and the 6x part by themselves. Okay, so that is what we're going to do first. We're going to add the 9. We're going to get x squared minus 6x is equal to 9. Okay, from here we are going to solve by completing the square. Now, completing the square will require you to do half of the b, the number next to the x. So we're going to do half of 6. And this first time that I do it, I'm going to show you the cheat way, and then I'm going to show you the official way of what we actually did afterwards. So we're going to do half of the 6. That's going to be x minus 3 in parentheses squared. We already had a 9. And then on the other side, we have to add that same half of 6, which was negative 3 squared. So we added it here and here. All right? So once we've done that, all you have to do is the 9 plus negative 3 squared, which ends up being x minus 3 squared equals 9 plus 9, 18. Now make sure you put parentheses in your calculator, because if you don't, the negative squared would end up being negative 9, and that would not be okay. From this point, you can square root both sides and get x minus 3 equals plus or minus the square root of 18. You're going to add the 3 over, and you're going to get x equals 3 plus or minus the square root of 18. Okay? Which sometimes this is the answer. Sometimes this is the answer. However, the square root of 18, if you break it down, you get a 2 and a 9 and a 3 and a 3. So you have a 3 on the outside and then a 2 left over. So this is going to be x equals plus or minus 3 on the outside. 3 plus or minus 3 square root of 2 would be the final answer. Okay? Now, remember how I said that we were kind of cheating the problem? What we really should have done, if we were doing it the fully correct way, would be to do everything essentially the same way, setting it equal to 9, just like we did before. And remember how I said you want to do half of 6 and then add that number squared to the both sides? So if we added the 3 squared here and we added the 3 squared there, you end up with a situation where you get x squared minus 6x plus 9 is equal to 9 plus 9, 18. Well, if you factored x squared minus 6x plus 9, which is factorable, which the original problem was not, what multiplies to positive 9 but adds to negative 6, that would be x minus 3 and x minus 3, better known as x minus 3 squared. Okay, so the official thing is to put a 3 here and square it, and then a 3 there and square it, and then write the 9, and then write the x minus 3 squared at that point. That is what we're doing all in one little tiny step when we just do half of 6, put it in parentheses squared. Okay, we're skipping all of those steps essentially and just knowing that they exist. So, that being said, same thing going to happen here, but you may notice there's another issue here. We have a 2 in front, but that's okay. See how everything here divides by 2? And because there's an equal sign, you can divide everything by 2, and it's not equal to y, so when we divide everything by 2, it just fizzles away. We end up with x squared plus 5x minus 7 is equal to 2. Now, we could have added the 14 first, but now I'm going to add the 7. We're going to get x squared plus 5x is equal to 9. All right. Well, from here, we now have to do the exact same step that we did before. We got to take half of that term, which is a 5. So I'm going to write 5 over 2 squared is equal to 9 plus 5 over 2 in parentheses squared. Okay? So we have x plus 5 over 2 squared is equal to, you're going to just do that all at once in your calculator. You're going to get your calculator out. You're going to do wait until it validates. Then you're going to do 9 plus 5 over 2, and then you hit squared. And you get 61 over 4. Okay? So this is equal to 61 over 4. Please do not write the decimal, write the fraction, because when we square root to get rid of the squared, you end up with x plus 5 over 2 equals plus or minus the square root of 61 over the square root of 4. Okay, well, the square root of 4 is a number. The square root of 4 is 2. So you get x plus 5 over 2 is equal to plus or minus square root of 61 over 2. And then you can just subtract the 5 over 2 over. You get negative 5 over 2 plus or minus square root of 61 over 2. There she goes. 61 doesn't simplify, that's why I circled my answer there. Next one. This one, we can't divide everything by 2. So if we can't divide everything by 2, then this is going to be annoying because we still want to subtract the 17, and we're going to get 2x squared minus 10x equals negative 17. And we're still going to want to divide by 2, but we can't divide everything by 2. So you actually have two options. You could factor out a 2 and get x squared minus 5x. Notice I didn't factor out the x. Is equal to negative 17. You could then divide by 2 if you want to. You don't have to, and it's a 50-50, is like what's best. So you could divide by 2 if you want to. I'm going to show you what to do if you don't divide by 2, which is now take half of that number, which is 5 over 2. 5 over 2 is half of 5. So we have a 2x minus 5 over 2 squared equals negative 17 plus that negative 5 over 2 squared. And then because there's a 2 here, we're going to multiply by 2 there. Okay, so whatever number is here, you also multiply there after you've done the halving and the squaring part. Okay, again, we're doing it all in our calculator. We're doing negative 17 plus the 5 over 2 squared times 2. All in our calculator. If you know that negative 5 over 2 squared is the same thing as 5 over 2 squared, and you get your answer is negative 9 over 2. Okay, so now we're at 2x minus 5 over 2 squared equals negative 9 over 2, so this is going to be imaginary. We have to divide by 2. If we divide by 2 here, you end up with x minus 5 over 2 squared equals negative 9 over 4, if you do it in your calculator. Okay, so again, you could have divided by 2 in this step, or you could do it later. Like in the beginning. It depends on what you want. So again, you could divide by 2 at the 17 step, or you could do it at the last step. We now have to square root, and we get x equals 5, x minus 5 over 2 equals plus or minus the square root of negative 9 over 4. Well, what is the square root of 9 and the square root of 4? That would be 3 and 2. So we are going to recognize that this is negative, so this is going to be plus or minus 3 over 2i, because it was square root of a negative number. And we're also going to have to add that 5 over 2 over, so I'm going to write that here, and I'm going to write my x equals, I'm sorry for doing it in one step, but I was running out of room. Okay, I'm going to save number 4. 4 is a much, much harder problem. I'm going to do it at the end of the video. It's a problem that many teachers may not ever present you unless you're in Algebra 2 Honors or if you're in pre-calculus. We are going to use completing the square to rewrite in vertex form. Remember that vertex form is y equals a x minus h squared plus k. So if we want to rewrite into vertex form, completing the square is one of the methods to do that. All right? You still probably want to add this 2 over. So if we do that, we get y plus 2 equals x squared plus 6x. And then from here, what is half of 6? Well, that would be 3. We're going to put it in parentheses squared. And then over here, we have the y plus 2. Now we just have to add that 3 squared. Okay? So what is 3 squared plus 2? 3 squared plus 2 is 9 plus 2 makes 11. Equals x plus 3 in parentheses squared. Then you would just have to subtract the 11 back over to get the y by itself. So we're going to get the 11 moved over. We're going to move it over here at the very end. It's going to be x plus 3 in parentheses squared minus 11. Okay? That's going to do that problem. The next problem has a 4 in front. So this is where you probably don't want to divide by 4, which is why I showed you not dividing by 2 in the first step here. We're going to subtract 5 over. Y minus 5 equals 4x squared minus 24x. Then we're going to factor out the 4. If we factor out the 4, we get y minus 5 equals 4 parentheses x squared minus 6x. Okay? Again, we could divide by 4, but then you end up with y minus 5 all over 4, and that's nasty. You don't really want to have to deal with that. And this is the a in the vertex form. The 4 is the a. Okay? So what is half of 6? That would be 3. So we're going to put that 3 in parentheses squared. And then we're going to have to do y minus 5. We're going to have to add that 3 squared. Technically, it's negative. And then, because there's a 4 here, we multiply by 4. So we have to do 4 times 3 squared plus, 4 times 3 squared minus 5. So 3 squared times 4 is 36. 9 times 4 is 36. Minus 5 ends up being a y plus 31 is equal to 4x minus 3 squared. Subtract the 31 over, y would equal 4x minus 3 squared minus 31. Okay? So, again, completing the square can be used to put it into vertex form. And we could get our vertex if we wanted to. It would be change the sign, keep the sign, 3 comma negative 31 to get our vertex. However, there is an alternate way to rewrite in vertex form. We could just get the vertex by using negative b over 2a like we did before in the past. Okay, so if we did negative b over 2a in this case, it'd be negative 6 over 2 times 1, which is negative 3. And then we'd get our x value, and you'd have to plug it in to get the y value. All right, if we plug in that x value, you get negative 3 squared plus 6 times negative 3 minus 2. If you do the math for that, you end up with negative 11. Well, we've already done this problem. It's the exact same problem, okay? So if we have our vertex using negative b over 2a, you have to change the sign, keep the sign to get your vertex, and then your a, this a is the same thing as that a, is the same thing as this a. They're all the same a, okay? So just put in the a value that you already used to get your vertex form. All right? Alternate way of completing the square here, still negative b over 2a would be positive 24. It would be negative 24 over 2 times 4. Ends up being 24 divided by 8, which is 3. If you plug in the 3, you'd get 4 times 3 squared minus 24 times 3 plus 5. You do all the math there, and you end up with negative 31. Same problem. That's how I knew it. Okay? Then you could change the sign, x minus 3 squared, keep the sign, minus 31, then plug in the a that we already had. And we get our vertex form. Okay? So, that's the majority of the problems. Number 4 is the hard one. For number 4, you may notice that 3 and 5 don't actually divide, and nor does the 8. So if we're solving here, we would still add the 8 over. We get 3x squared minus 5x is equal to 8. Then, in this case, this would be a problem where I would recommend just dividing everything by 3, because it's going to be nasty and ugly either way. So let's just divide everything by 3. We get x squared minus 5 over 3x equals 8 over 3. So I just put a 3 underneath every fraction, and then it canceled over here. Now I'm going to do half of this term, because we always do half of the number attached to x. Well, half of 5 over 3 ends up being 5 over 6. So I put that in parentheses squared, and now I got 8 over 3 plus that same 5 over 6 in parentheses squared. Technically, it's negative. From here, you put it in your calculator, because I don't want to deal with those many fractions. So we got 8 over 3, not 83, 8 over 3. And then we're going to have to add the 5 over 3. It's technically negative, I know, but when you put it in parentheses and you square it, it ends up being a positive, and you end up with 49 over 9. Okay? So this makes x minus 5 over 6 equals 49 over 9. And it's in parentheses squared. So the next step would be to square root. When we square root, we get x minus 5 over 6 equals square root of 49. And the square root of 9 is going to be plus or minus 7 over 3. Then we would add the 5 over 6 over. We get 5 over 6 plus or minus 7 over 3. Now, because this is square rooted and it's not imaginary, you should technically add those things together, because that is what a plus or minus technically is. So if I do 5 over 6 plus 7 over 3, I end up with 19 over 6. So x would equal 19 over 6. And if I did 5 over 6 minus the 7 over 3, I would get negative 3 over 2. Now, when it perfectly square roots like this, that technically means that this was factorable, and it is. If we factored this problem, you would realize that negative 24, when you multiply the 3 and the 8 together, can multiply to 24 and add to 5. So that's why we got two real answers here. And let's see what happens if we do factor it. You end up with x minus 8 and x plus 3. Uh-oh, I think I made a mistake somewhere. If we divide them both by 3, we get let's see where my mistake happened. Looking. 8 over 3 plus that. 7 over 3. 5 over 6. Looking. I don't see it yet. Where is the mistake? Multiply to 24, add to that. I'm just talking to myself now. You can feel free to leave if you would like to. So we got 3 times 8 is 24. We have multiplying to 24 and adding to that would be 8 over 3 and 3 over 3, and we divide them both by 3. So we should have these answers matching up, and they don't. Wonder what happened wrong. All right, 5 over 3 divided by 2 is 5 over 6. Got that part right. 8 over 3 plus 5 over 6 squared. There's the issue. I might have typed in the wrong number a while ago. 8, I typed in 5 over 3 instead of 5 over 6. A long time ago, I typed in the wrong number. So technically, this would be 121 over 36. And the square root of 121 is 11 over 6. So this would be 11 over 6. And when we solve those, we end up with 8 over 3 and negative 1. Okay. Sorry for the mishap there. Imagine how one little typo can mess you up. That's going to do it for this one. I did tell you that number 4 was not one that you would typically have to do. Stay positive, my friends, and I will see y'all later. Bye.